So now we're going to look at parallelograms. Now a parallelogram is a quadrilateral such that the opposite sides are parallel. So I've drawn one here. Notice I'm calling this one ABCD right here. And you'll notice that I'm denoting which sides are parallel by these little arrows. Notice this has a single arrow and that has a single arrow. So those are parallel. And then the others, double arrow, those two lines are parallel. Now we're going to study some properties of these parallelograms mainly with these four theorems. We've got 6.2, 6.3, 6.4, and 6.5. And I want to focus on, first of all, this first theorem that says if a quadrilateral is a parallelogram, then its opposite sides are congruent. In other words, what we mean by that is this side here is congruent to this side, and this side here is congruent to this side. Same length. So what I want to do is kind of set up a structure for how we would build a proof for that. Now, I've drawn a diagonal in here. Of course, that wasn't part of the original. You know, I could take that out. There's the parallelogram, but then I'm going to add this diagonal. Okay. And now you notice I've got two triangles formed here. I've got the triangle ABC. Okay, so let me see. The triangle ABC, let me just kind of color that in. That's over here, this yellow, ABC. And then I've got another triangle, this one up here, and I'm going to call that one CDA. Yeah, CDA. I think those line up okay. Now, one of the things I want to do is I want to take this segment AD and I want to make kind of a line out of it. So let me go down here. There's that segment here. Okay, I just moved it down, took it out of the clutter a little bit. And then I have another segment, BC. Let me move that down here as well. Whoops. Okay, here we go. Okay, so I've got those segments down here. Now, think about the diagonal. Okay, so I'm just going to draw a diagonal through here. And there it goes. So that matches to that diagonal AC. Now, what we have here are two parallel lines, this one and this one, cut by a transversal. And that's really what we have up there with that parallelogram. And notice the alternate interior angles are going to be congruent. So this angle is congruent to this one. Now, you could do the same thing with, you could make two parallel lines cut by a transversal, but this time use DC and AB if you wanted to. And if you did that, you would find that this angle, this angle is congruent to this one. So we have these two triangles. And notice that one additional thing is that AC is congruent to itself. And of course, that's the reflexive property. Okay. So it looks like these two triangles are congruent by angle, side angle, ASA. Okay. See, we've got an angle, we've got a side, and we've got another angle. So we've got angle, side, angle congruence. That means that the corresponding parts are congruent. That means the opposite sides are congruent. Now, there are other theorems here that we can take note of. You've got if a quadrilateral is a parallelogram, then its opposite angles are congruent. We could prove that in the same fashion as this one. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. If a quadrilateral is a parallelogram, then its diagonals bisect each other. That's pretty cool. So you draw the two diagonals, and they're going to be bisectors of each other. So let's see how we would use this information here. I've got FGHJ is a parallelogram. Find the unknown length. Well, I've got 3 here. That means that this is 3. So this JK is 3. And I've got this is 5 up here, so this bottom one must be 5 as well. See, super easy. Now, if PQRS is a parallelogram, find the angle measure. Well, angle R would be 70 degrees. See, we're working with this thing here. This is 70. And let's see here, Q, well, that's going to be supplemental of the 70, so that would be 110. There we go. Now down here, I'm working this already. Okay, so this one down here, PQRS is a parallelogram, find x. Well, we know this. We know that 3x plus 120 has to equal 180 because those two angles are supplementary. So there we get 3x is equal to 60, and that means that x is equal to 20. Yeah. So that does it. Now, I've given you some assignments down here, and they're basically, these types of problems using those theorems.